Hi. In this video I'm going to take a look at 2013 question 1, and in particular part F of the question, where I'm dealing with volumetric analyses. So the relevant information is listed here. We have 200 cubic centimeters volume of water with some iodine in it, and that's reacting with 0.02 moles of sodium thiosulfide. And the average volume of the titre was 9.4 cubic centimeters. So the balanced equation for this reaction is given, and we have to find the concentration of iodine in the moles per liter. So that's the first step to take. Now, the way I'm going to deal with this is I'm going to use the equation for every titration from volumetric analysis, where I know that a number of moles of molarity of acid by volume of acid over the number of moles of acid is the same as molarity of the base times the volume of the base over the number of the moles of the base in given titration. I'm going to treat sodium thiosulfide as acid in here, so molarity of the acid is equal to 0.02. Volume of acid is given, it's 9.4 cubic centimeters. And then the last thing is that I need to know the number of moles of acid taking part in the reaction, and the balanced equation tells me that there are 2 moles of acid. And in a similar fashion, I need molarity of the base, which I actually don't know, and this is the thing that I'm going to be trying to find out. I need volume of the base, which is told to be 200 cubic. And finally, the number of moles of base taking part in this reaction is 1. So by putting those quantities into my formula, let me change the color maybe to this one. Maybe first what I'm going to do, I'm going to transpose it. I'm trying to solve it for molarity of the base. So multiply above and below by NB and divide by volume B to get that molarity of the base is equal to molarity acid volume acid times number of moles of base, all that divided by number of moles of acid times volume base. And if I substitute in, Ma is equal to 0.02, Va is equal to 9.4, Nb is equal to 1, all that divided by Na, which is equal to 2, multiplied by 200, to get the molarity of this solution to be equal to 4.7 times 10 to minus 4 moles per liter. So that's the molarity. First part of the question done. Then, for every 1 mole of dissolved oxygen in the water sample, 2 moles of iodine are liberated in this experiment. And note that these are the moles of iodine that are going to be detected in the titration. So this is the number of moles of iodine is going to be pertinent to this part. So for every 1 mole of dissolved oxygen, 2 moles of iodine are liberated in this experiment. Calculate the concentration of dissolved oxygen in the sample. So then part I know that for every 1 mole of dissolved oxygen, I'm getting, so here is O2 and here is iodine. I'm getting 2 moles of iodine. Now in this titration, I just calculated that I am using 4.7 times 10 to minus 4 moles of iodine, moles per liter. So to find the concentration of in moles per liter of oxygen, I simply need to divide this by 2, because I know that 4.7 times 10 to minus 4 moles of iodine would be released if a certain number of oxygen molecules were present in 1 liter of water. So from here I know that X is simply 4.7 times 10 to minus 4 divided by 2, which is equal to 2.35 times 10 to minus 4 moles of oxygen. So the concentration is moles per liter. Then the next part is in grams per liter. Now I know that relative molecular mass of O2 is equal to 32. So to find, so I know that 1 mole weighs 32 grams. So the question is, how much does 2.35 moles, sorry, not 2.35, but rather 2.35 times 10 to minus 4. Equals to x. So from here, simply x equals to 2.35 times 10 to minus 4 times 32, and that gives me a value of 7.52 times 10 to minus 3, which can be written as 0.00752. So 0.00752, which can also be given as 7.52 milligrams. And I hope that you can recognize that the reason I'm doing this is because I'm going to apply, I'm going to use the number of milligrams to find the answer to the last part of this question, which is the concentration of dissolved oxygen in parts per million. So what I know is that I have 7.52 milligrams, and I want to find out the number of parts per million. And I know that 1 milligram is 1 part per million. So therefore, by multiplying and dividing, I know that question mark equals to 7.52 ppm. And as always, it's like in the previous case, once I know the concentration in grams per liter, so this concentration here, once I know the concentration in grams per liter, by knowing that 1 gram is 1,000 milligrams, I can convert that concentration into parts per million, because 1 part per million in liter of water is 1 milligram. So that's it for this question. As always, if you have any anything to ask, you can leave me a message either in the comments or send me a DM, and I'll be more than happy to answer your question. So thank you for watching. This is Mr. Oziak out.